Yeah, welcome you all to this session. Today, what we are going to look at complete overview of convolutional neural network architecture. This is one of the deep learning algorithm. Bits and pieces also not required. Directly, we are stepping into understanding of convolution neural network. So this convolution neural network, little fundamentals already have been shared in the previous video. You can watch that video for the continuation purpose. So today, directly I'm starting with a little background of reiteration, then stepping into simple mathematics behind of this and coding practices if required. So again, it is a fundamental. Further, next upcoming session onwards, systematically we can step into understanding of convolution neural network. What for primarily, predominantly in the research world or in the application world, convolution neural network is used for image-based activities, image analysis, image-based activities. That much only I can say. Within image, what and all we can do? Image classification or image recognition. See, for example, this is the image, whether it is zebra or horse or dog. So we need to finally, the machine need to recognize, or suppose if it is a medical image, cancerous tumor, non-cancerous tumor. We may need to classify. Finally, we need to tell that exact analysis of the image. This is one. N number of applications you can imagine. So even face recognition, it could be anything. Then if you look at another aspect of this image, segmentation, for example, brain image, so brain MRI image, it has all of the regions, but my interest is to analyze either disease, or for healthy people we used to do cognitive profiling, so their cognitive ability, IQ analysis. There's so many things people are doing with the brain. I want to extract particular region, particular lobe, particular segment of the brain. So that is said to be segmentation. uh, Taking my eyes alone in this picture, taking this portion alone, this is segmentation. Interested area of an image, whenever we are extracting, that can be said as segmentation. This is one application. Again, I will tell you one interesting application using convolution neural network only. It is possible 100%. um, this will work, but we can even use different statistical method, feature extraction method for the application what I am going to tell. What is application is, exactly 2 months ago I have attended one of my relatives marriage occasion. In that marriage occasion, they have displayed QR code in several instances. What is that QR code is, each one of us whomever participated actively into that marriage function, for example giving the gift and taking group photo or dancing or something like that. So when that QR code, when we take, it is asking for OTP, whatever that number. Then after all of the formalities, it is asking to take my photo. Only one selfie, clear crystal selfie we may need to give. Then after 3 days of that marriage ceremony, what they were doing? Completely they started collecting wherever I have appeared in this marriage ceremony, with a photographer or photography. Those all of my pictures, it started sending to me on WhatsApp. Then I can view. Among all of it, just I was looking like this, that also they have taken in the crowd. Precisely, it started detecting my face. Then, whichever I want, I can download or I can ignore everything. Likewise, every member, whomever have taken that QR code, whomever have participated in the wedding ceremony, whomever have come into the photo frame, all of their picture alone have been sent. This is one of the contemporary era or this recent age I find very interesting. Another application, every day, institutions after pandemic, most of the organization and institutions, they started installing attendance biomarking system. So we need to appear. So the moment we appear, it is recognizing and it is telling, welcome, Dr. D. Lakshmi. So it is trying to tell my name, then our welcome, thank you, something it is telling. That is acknowledgement that my attendance is recognized today. These are all some of the applications we can say. with images. Numerous activities people are doing with images, even video analysis, traffic camera. Now, what is the purpose of traffic camera? Whomever violating the traffic rule, their nameplate will be captured, immediately analyzed, then penalty is issued, or that will be registered under the criminal activities of RTO office. These are all happening, and who are all violating the traffic rule, who are all violating the lane in the national highway lane rule, who are all violating the speed control. Everything it is deducting. So many applications, right from medical application, industrial application, and we can keep on telling image based application. Predominantly, people are using. Even there are a lot of research papers. People are applying this CNN in several other interventions also. Now, whenever we use deep learning, machine learning, the primary fuel of that model is data. We need to get the data. Data should be ready. That is the first condition. Recent days, plenty of platforms started providing a data set so we can utilize. For learning purposes, the available data set itself is more than sufficient. Whenever we are working on product or project or research, we need a specific data set which is suitable to our research problem statement. That time only data crisis will arise. Until then, for academic activity, data crisis is not at all an issue. Let us keep aside. Now imagine we have animal database, collection of animals, but similar animals. Dog, zebra, lion, and tiger, and horse. These all more or less it will look similar height, weight, and pattern only will they vary. We the human being can able to recognize easily, but how the machine is going to understand, that is what the discussion now. For example, every image the machine learning algorithm needs to understand. Every image needs to be trained. How we are trained in our brain. Whenever the pattern of black and white with lines, alternative lines comes, that is zebra. It is fixed in our mind. Whenever so and so pattern is there, that is lion, that is tiger, we are started extracting lot of features within that animal. Not only that pattern, we learn through the sound, behavior, all such things, but machine can learn only through that image. That's all. So that only two-dimensional image, more or less. RGB means three channel, but it is 2D only, two dimension only. So with that limitation, machine need to learn. So with that, let us confine again. It is an image, two-dimensional image, but RGB color, three channels, color channels. So we are considering this as one of the picture. The very primary role what is happening within the convolution neural network is convolutional layer or convolution layer. It is little simple mathematics only, but it is said to be convolution layer. That convolution layer is a first activity is happening, or that layer is playing a pivotal role. What is layer? In the previous class it is mentioned. So in the convolution layer, primarily people will apply lot of filters or kernel. Either one of the word we can utilize, either kernel or filter. Both are interchangeably same. What is the role of filter is, this yellow color box is filter. You can imagine that filter is 2 cross 2, 3 cross 3, 5 cross 5, we can fix. Even 7 cross 7. Again, it is one of the hyperparameter. Hyperparameter is a terminology, a technical terminology in the deep learning. What is the meaning is, the way of fixing that value can vary from one range to another range. It can be 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5. Neither it should be too smaller, nor it should be too higher. Always this is a formula. This is a fixed mantra for the hyperparameter. Too smaller, let us imagine two. What is kernel or filter? First, let me explain. Kernel or filter is useful for extracting important features, patterns, texture, edges, contours. These all said to be a component of an image. These are all part only machine is trying to learn. Each of the kernel tend to learn different matter. For edge means what? See, face, this is my edge. Nose edge, mouth corner edge, eyes edge, everywhere edges. That edge only separates every feature of the face. So that edge detection, certain filters or edge filter you can call. Then texture. Texture is varying, right? The texture of this eyebrow is different. Eyelids are different. Texture of the cheeks are different. Similarly, the texture, it starts understanding. And contour, it is also a boundary, a kind of pattern, it is understanding. So these are all the features it starts extracting. Ultimately, what is a feature? Numbers. It is a number game. Image itself is a matrix. 48 cross 48, 100 cross 100, 128 cross 128. It's a matrix. Within this matrix, each and every component of the matrix is said to be a pixel. What is pixel? It is after all a RGB value. Since it is RGB image, RGB value, grayscale image, then grayscale value, it will vary. That's all. It is ultimately a number. Each and every pixel can be represented using numerical number, full integer number, numerical number. That's all. So now that number game only happening. So there is a kernel in which certain values are there. What value? Let us see later. Those values are overlapped with, this is my kernel, my right hand, left hand is my image. It will be overlapped, 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 overlapped. So this overlapping, this yellow will start from this corner and it goes on, goes on, goes on, goes on. So that is the way it will go for horizontal sweeping, horizontal sweeping, horizontal sweeping. It starts sweeping the entire image. While sweeping that entire image, it starts extracting a lot of features. Those features are said to be convolutional layer or convolution feature. That's all. So it is raw image. After this kernel, it's a matrix multiplication. Simple matrix. This entire image will be decomposed into small, small, small matrices depending upon the size of the kernel. Kernel is also a matrix. How that matrix is formed, what is the value, that little later. Now the periphery level overview of understanding. So that kernel is a matrix. Your image is a big matrix, biggest matrix. So that kernel size only, we are taking a portion of the original image. An original image portion is taken. That original image portion, how you need to take depending upon the kernel size. Your kernel size, let us fix as of now 3 cross 3. Within the image, we need to take the first 3 cross 3 matrix. So now simple multiplication only happening between 3 cross 3 matrix and here 3 cross 3 matrix. So this simple dot product only will happen. Dot product, not multiplication, dot product only will happen. So that dot product value is said to be an convolution layer. That's a convolution values or layer. So this convolution is ready. That's it. Again, it is a matrix, nothing to worry. Matrix operation leads to another matrix. That much is more than sufficient as of now. Now, next, what is happening? Every one of us highly comfortable with the matrix, understanding about matrix, what is matrix basic operations. That is more than sufficient. Now, next new word you may come across, that is called ReLU layer. What is ReLU? It is said to be an activation function. What is that activation function? Is every number which we have brought after the operation. I said some operation, right? Between the image matrix and the kernel, some matrix operation is happening. That's enough, that imagination. That resultant matrix is said to be convolutional value or convolution layer. Now that convolution value may be 0, may be near 0. When it is becoming near 0, maybe 0, what will happen? It will become linear. Linear means deep learning is not at all required. Simple machine learning, simple statistical approaches is more than sufficient to understand linearity. What is linearity? Let me make you to understand through this. Look at, when the temperature is rising, ice cream sale will also increase. It is linear relationship. When the temperature is decreasing, ice cream sale also will decrease. It is a linear relationship. Another example I will tell you. When the speed of the vehicle is increased, distance or hours will be reduced, drastically reduced. If I ride a car in 50 kilometer per hour, 50 speed, then how the car will reach 100 kilometer if I increase the speed of the car to 60, 70, 80, 90. Again linear, it is depend, one is increasing, another one is increasing, one is increasing, another one is decreasing. It is like that, increase decrease game. That's it. When I am reducing the amount of food daily which I am eating, my fat also will reduce, my weight also will decrease, reduce. It is directly linear relationship. When I am increasing my exercise, my weight will reduce. It is also linear. One is increasing, another one is decreasing. It doesn't matter, but it is linear. Both are increasing, linear. Both are decreasing, linear. One is decreasing, another one is increasing. Another one is increasing, another one is decreasing. All are said to be linear. For the linear analysis, or in general, linear analysis is to be simple pattern. For that, machine learning or neural network is not required. Sorry, deep learning is not required. So we may need to use deep learning only for the complex pattern analysis. When you call it as complex pattern, whenever non-linearity exists. What is non-linearity? All other shape, moon is non-linearity shape. Data relationship forms moon, half circle, parabolic, hyperbolic, quadratic, cubic. These are all said to be non-linear relationship. Simple way of understanding, you can look at here. Linear and non-linear. Just look at the function, how it is working in that image. Just go to image, look at, this is non-linear, this is linear, easily separable. Boundary you can put easily. Boundary can be given easily. See, this is linear, this is non-linear. Non-linear pattern always will be complex. Non-linear, linear, non-linear, non-linear, linear. Straight line is linear. Any other shape is non-linear. This is linear, non-linear. You can learn in any method. That's it. Linear analysis, simple statistics, or machine learning is more than sufficient. No need of deep learning. It's a costly affair. So what we are trying to do with the ReLU is we are trying to maintain linear, non-linearity. Even the data happens to become linear in the series of activity, our primary duty, our caution is not to make the data to become linear, always to maintain the non-linearity. That is our primary goal in the deep learning, especially CNN. Between sequence of operation or in the pipeline, data nature should become non-linear. Between dependent to independent, between independent, every level it should become non-linear. That is a primary condition. So for that, predominantly people are using ReLU layer, ReLU activation function. What is ReLU activation function? This is simple. Any of the value less than 0 or near 0, it will make 0. Any of the value above 0, it will give as such above 0. See, this is the function. Max of 0, comma input. I am asking you, say some random number, minus 27 you are telling. What is the value? 0, comma 27. Which is maximum? 0 is maximum. It will give 0 output. Suppose I am giving random number. You are giving 0. That is what you are interested in giving me the input. Then what will happen? 0, comma 0. Which is max? 0. Now I am asking you, give me a random number. You are giving me 100. Now look at it. Max of 0, 100. What would be your output? 100. That's all. Nothing more to worry. That's why I'm telling ReLU is simple mathematical operation. It will, if any input is given to ReLU, if it is 0 and less than 0, it will produce output as 0. If any input is given to ReLU above 0, it will produce as such. That's all. This is mathematical graphical function. 0 and less than 0, always 0, plain tone. If it is above 0, as such, if your input is 1, 1, 2, 2, 3, 3, 1 lakh, 1 lakh, 100, 100. That's it. So mathematically, how you will do f of x function? What is x? Your input. That x can be negative value, positive value, or zero. Only these three are the possible values. Whenever you are using the function max of 0 comma x, 0 and less than 0 will be 0, above 0, it is always as such. That's it. Other than ReLU, leaky ReLU, tanh, sigmoid, so many other activation functions are available. For that, again, we need to spend a lot of time understanding about all of the available ReLU means activation function and what is the impact when we use each of the activation function. It is all well written in this document, in this material. Right now, let us not to step into that, but try to understand. Always we need to maintain the linearity in the pipeline of convolution neural network. That is our primary objective target. For that, in this scenario, it is used ReLU. That's it. Now ReLU. Next, immediately, if you look at this is pooling layer. The in between these two, one pooling layer will happen. That output is not shown here. I will show you through one animation. Excellent animation is available. Through this, I will show you. Now, what is happening? We are not stepping into deeper understanding through one image and one image animation today. That's it. What is pooling layer is slowly the largest image or large biggest matrix, the higher dimensional matrix will be brought down to lower dimensional matrix. How is it possible? Next question you will ask. Simple. For example, again one matrix you need to form here. This yellow boundary, 3 cross 3, 2 cross 2, 5 cross 5. That is again hyperparameter. How to fix? Neither it should be too small, then operation will take a lot of time. That is why neither it should be too small, nor it should be too bigger. Then we will miss out all of the points. For example, I'm just giving boundary. This lot of dimples are there. If I give this boundary, you can count on my nose how many dimples are there. If I say how many dimples are there, will you count? Only prominent features only you will count. The biggest dimple or pimple, let us imagine. So, given the region, how many pimples are there, you can count easily. Simply, how many pimples are there on my face, you don't even bother. Only whichever prominent, easily you will count. You will miss out the micro level feature. That is what I'm trying to tell through this anecdote. Here, that max pooling layer, neither it should, that matrix, neither it should be too high nor it should be too small. Now that is done. Now, what is the role of max pooling layer? Pooling layer is in that 3 cross 3 window, we can pick the maximum value, that is max pooling layer. We can pick, we can do averaging, that is average pooling. Types of pooling layer, pooling techniques are available. That also let us keep it aside. Right now, let us consider only max pooling. What is max pooling? Imagine this window, it is here. Among this window 3 cross 3, which is the highest value? Maybe 24, maybe 48, maybe 408. That it will pass out. That's it. That will be the output. Next, it will keep on sliding, sweeping, sliding, sliding, sliding. Then it will do. Imagine now how much reduction is happening. That is what. For example, on my face, here one window formed. Highest resolution, what is there? That only will be output. That is what happening. That is pooling layer. Upon that pooling layer, now reduced matrix, important features are highest dominating pixel values. That way we can say. Dominating pixel values are available in the pooling. Now for that pooling layer, we are applying again convolution layer. Why? Because this kernel, what is learned is said to be weight. That weights only will be guiding for the recognition of the unseen images future. For example, attendance. My faces are five. Five faces only they have taken when I joined. Five poses, this, distance long. Five photos only they have taken. Till date, it is recognizing. I'm keep on changing my hairstyle. Every 6 months once I change my hairstyle. Then I wear spectacle without spectacle also. I change my ornaments. I change cosmetics. How it is recognizing till date for the past 4 years, the same machine is recognizing it to be here. So how it is possible? It starts learning prominent features. That's it. So now what we are doing here? Convolution layer. Again, we need to learn that weights what it is learned from my original 5 phases. Those weights are guiding for even today. That is called deep learning. Weights. What is weights? That is the secret of this deep learning. That's all. So now again, we need to apply the same kernel on this pooled data. Now again one more convolution is happening, ReLU is happening. Again for this small matrix, we are applying one more pooling. It is miniaturized. Again we are pooling. Finally see, this image has been brought to one small square look at. That is the final image. This is the stage we have reached. Subsequently, flatten layer. It is in the form of matrix. After that, matrix operation is not possible to proceed, so that or not you can even do any other operation also. Original, the very first invented CNN model we are talking, we can reconfigure. Now what we are doing, this pooling layer, it is in the form of matrix that we are straightening. That straightening is said to be flatten layer. What is straightening? Nothing. For example, imagine this matrix finally 1 2 3 4 5 6 7 8 9. It is in the matrix form. Now I need to write linearly like LKG student. 1 2 3 4 5 6 7 8 9. That's all. That is said to be flattened layer. Nothing more to understand. Simple. It is 3 cross 3. We are making it to and vector. It is a vector. Matrix is to be converted to a vector. That's all. That is called flattened layer. Then what we are doing? Fully connected layer. In this fully connected layer, again certain mathematical, this is the flattened layer. Instead of this, we are making neuron. Then another convolutional neural network we are making. Then multiplication is happening. Every feature is given as input to every neuron. Again, simple mathematical operation, nothing to worry. Then every neuron is trying to learn feature of all of this flattened layer. That's all, vice versa. From that, lot of other operations are happening. Right now, let it be. Now, finally, it is going to become probability value 0 to 1. That's all. Every image, whatever the image you give, for example, it is collection of animal. If you try to give my picture, it will be ending up with certain probability value. Every image, lion, tiger, zebra, horse, my picture, everything will be converted into one probability value. Now here what will happen is another activation function people are using, that is Softmax. It is clearly given probabilistic distribution. This is feature extraction. Here only the classification is happening. This is fully connected layer. In the probability, Softmax, that is one mathematical function, one formula. As of now, that is enough. That Softmax activation function, how it is working is, it will start fixing the lower limit to the upper limit for one class of category. Zebra means 0 to 0.1. Horse means 0.1 to 0.2. Depending upon number of images. For example, 10 inputs only I'm taking in the category of animals. Then what would be the softmax value is 10. 1 divided by 10. It will be what? 0.1. Then 0 to 0.1 will become one of the animal, 0.1 to 0.2 will become another animal, 0.2 to 3 will become another animal, etc. In case number of images are 50, what will happen? 1 divided by 50, 0.002. 0 to 0.002 will become one animal, 0.002 to 004 will become one animal, etc. It's more than sufficient for you to understand as of now. So within that value, whenever in the near future also, you may bring different zebra, small baby zebra or old age zebra, little different orientation, different size, whatever you bring, It will start extracting the features, then it will fit into that range. In case if it is fitting, then it will tell zebra. In case if it is not fitting, it will tell not a zebra or misclassification. Sometimes it may be a zebra, it may misclassify, sometimes it may classify appropriately. That is called model validation. Finally, I am testing my model with 10,000 images further or 100 images further. Among that 100 images, 80 images are zebra, other 20 are cat, dog, monkey, something. Then how it is predicting that 100 images, how exactly it is predicting what I labeled, what is the original, what my machine is telling. That discrepancy only people are trying to tell accuracy, loss, this all model validation. I am showing you 5 objects. This object, this object. How many you are trying to tell correctly? That is called classification, right? The same we are testing with the machine. This is a static picture. Now let us move into animated picture. Now if you look at, I can pick any of the image. This image is red channel. Okay, this cup I am picking. There are ball, cup, and some cube is there. So a panda, red panda. These are all the object. Let us imagine a teacup, cup with a tea, in which it's a color image. So naturally it has 3 channel, red, green, blue, RGB channel. That is what it is happening. Red channel, green channel, blue channel. The original image is a pixel. Every pixel, 3 colors are contributing to constitute a pixel. So what proportion of green, what proportion of red, what proportion of blue? First level, it will be divided into 3 different matrices because 3 channels. So all of the separate channel, what is happening? Let us see. See, convolution neural network is happening. This image, every image, see, if I magnify, you can understand. See, kernel, fast it is running. Wherever my mouse is there, that is running. That window, that is kernel. That small, tiny black dot. This black dot, I may not able to see. Look at that black dot. That is a kernel, 3x3 matrix. Now, original matrix is what? Cup. Within that cup image, background, that dining table, everything is there. Now, this all of the part of the image, the kernel is overlapping and it is a simple dot product. That's all. What is the kernel value? One cross, that first cell, first row, first column, 1x1, what is there? Similarly, in the image, 1x1, what is there? That is placed. Then output, it is giving output. See, this is what related to output. Now it is appropriately capturing this cup alone. The rest of the background is diminished. That is how it is learning. Now next. So now if I do this, similarly what is happening? So this another term bias that we will discuss little later. Now look at ReLU. What is ReLU is happening? Every pixel, look at highest negative value is there. That's why 0. Look at if I move, positive value is there. So that positive. So it is giving what is the value available, that value max of 0 comma, that information it is giving. That is output. Now again convolution layer. Now look at max pool layer. Maximum value will go. See, look at max of the 2x2 is going. That wherever that black color, see, it is moving, animation, that kernel, or it is a window, pooling layer window. That 2x2 is demonstrated here. So the 2x2, 4 values only will be available. That max of 4 value will become 1 output. That is what pooling layer is doing. Then again convolution layer, again convolution layer, again ReLU layer, it is happening. So again max pool layer. So finally it is telling that lifeboat output, lady bag, pizza, after pizza bell pepper, school bus, something. It is classifying each and every component. Say sports car, 0 to 0.99. This is the probable value. Within that probable value, it is fixing for every one of the object. Now this is one of the best material. What is tensor? What is neuron? What is activation layer? What is kernel weight and bias? Bias is the point we are going to discuss a little later. Now convolution layer. Every layer try to understand first because it is convolution neural network. We need to understand primarily about convolution. So what is convolution? This is what again detailed manner they are discussing. Say convolution again. Black color, that is kernel. It is going everywhere. Now, today we are ending up with what is kernel. That is the next topic. Now, holistic is done. First kernel we are going to discuss or filter or kernel. Look at here, it is completely showing animation. I no need to intervene. So intervene with that. So plus that yellow color values. You can even understand how the convolution operation finally equal to this into this plus this into this plus this into this plus this into this plus equal to. So how it is produced, that is what it is showing convolution. Next, understand hyperparameter. This one point we may need to understand before even kernel towards holistic understanding. Now look at here, this pink color is kernel. How to form the kernel? That's what first point we are going to discuss about CNN today. Just imagine as of now, pink color is kernel, gray color is image. What is that image? Don't ask question. It can be any image. That's all. It is a matrix operation. Always kernel will be miniature. Now imagine input size you can increase up to 7 cross 7. It is their demonstration purpose. They are showing you. You can fix any size. 7 cross 7 maximum I have fixed. Now what we are doing? Padding. What is padding is outside of the image. See, this kernel starts moving 1, 2, moving 3, 4, 5. If it is one stride, that movement is said to be striding. See, this word is coming. This, how I am moving. 1, 1, 1. See, adjust sequentially I'm moving. This is stride 1. If here I'm skipping, here I'm going. That means stride 2. 2 I am skipping, not 1. That is stride 2. When I am doing stride 2, what will happen? See, when I am coming here, only one level is there. After that, I don't have anything. How the matrix will multiply? It is non-trivial solution. One number cannot deal with the space, emptiness. Empty and one number cannot communicate each other. So to avoid that, we need to artificially bring one layer with the zeros. That is stride. Look at one stride. Now let me do 0, 2 stride, 3 stride, 4 stride, 3 stride, 2 stride. I will show 2 stride. Now pad. This is what striding. 2 stride. What happened? That pink is not coming. Okay, stride, 2 stride. Yeah, 1 stride. 2 stride itself it is not allowing. Okay, that's it. Moving, skipping, that's it. That's all. 2 stride. It is not coming. 1 stride only it is allowing, but it is showing what is stride. That's it. So when single stride, no need of any single movement, sequential movement, no need to worry about stride. When we need to worry about stride, see here 1, I'm skipping not 1 cell, 2 cells I'm skipping. I want to go here, again 2 cells. Then I want to go here. Now what will happen? The last column, either I need to leave, maybe important features available, or if I want to process, what will happen? Then adjacent layers are not available. Adjacent columns are not available. So that according to the stride, according to the, according to the stride only, according to the skipping, we need to add stride. That's it. Now padding. This is padding. See, stride is movement. 1 movement, 2 movement, 3 movement. According to striding, padding will happen. It's a little confusion, sorry. According to striding, padding will happen. See, now additionally, it is done. Now stride 2, 3. So this new layer with 0 is created. That is not at all image. Simple 0. For matrix operation, in order to support, we are creating additional layers. Even all four sides we need to do. That is padding. So now padding is 0, padding is 1, padding can be 2, 3. That is also hyperparameter. Now kernel size. Kernel size 2, 2 in the sense this 3. This is 3. Now 2. Initially it is 2. The kernel size is 2. Now kernel size is 7 or 5. Kernel size is 5. It is sometimes it is not playing a role. Yeah, kernel size is this stride only creates trouble. See, kernel size 3, kernel size 2, that pink you keep on noticing 4. That's it. So this is one of the excellent what to say website I have come across to make for the beginners to learn. The purpose of beginners to learn or novice learner can use this material. That's it. Now what is padding, what is kernel size, what is stride, it's all available. Now activation function, this also we have seen using Google search. Now we are seeing here within this material, this is the function, mathematical function, max of 0 comma x. X is input, ReLU of x. Whatever we give input, that plays a role in the function. Now less than 0 or equal to 0, output is 0. Above 0, it is same as that. That's it. Now this is the softmax equation. X what to say exponential logarithm. That's it is a kind of logarithm, exp of x divided by summation of exp of x. That what is the meaning? 10 images, every image, whatever the probability we are getting, for every probable value we need to take logarithm, then summation of that, then what image, what probability we got, that probability divided by, that is some softmax. This is how it fixes the range 0.1 0.1 to 2, 0.2 to 3, 0.3 to 0.4. It is fixing depending upon the number of classes. Every class, what is the probable value, then particular class, how to find the softmax value. This is the formula, use it. Okay. Now softmax, it is done. After this, flatten layer. What is coming? Yes, softmax interactive formula. So how it is fixing this softmax value for every image, for every layer? It is again giving interactive way or visual representation or animation. Next to pooling layer, finally flatten layer. Interactive features, upload your own image, anything, whatever you say. Change the activation map color scale also. They are giving flexibility for you to adjust, you to configure using this. Further, based on this animation, lot of tutorial videos available. If you wish, you can watch. Now, let us stop at this point. Now we move on to kernel. Now, how we are going for kernel? 1 minute. Um, so her kernel size is also hyperparameter. Now I am looking at what are all the way small kernel, large kernel, that all, what is the impact? Every question, every parameter, investigation answer is available. Now I'm searching for one of the material. Wait a minute. I scroll it. Kernel, I need to common ways of initializing kernel. That is the title I have given. What are all the way initially kernel will have? That is the first point we need to discuss, because that is the very first operation we are doing it with the convolution neural. Yeah, common initialization methods for kernel or filter. Again, it is a mathematics, simple. That's it. Now, within this he initialization, it is called he normal initialization. That is one technique. In this initialization method, what is happening is normal distribution they are considering. With what is a normal distribution means, always mean of that normal distribution will be 0. Standard deviation of the normal distribution will be square root of 2 divided by n. N is the number of units it is available in the layer. For example, 3 cross 3 kernel, whenever you are using 9. So the distribution value will start with 0 to square root of 2 divided by 9. Within this range, it will randomly pick the values. It should be normally distributed. So what is normal distribution plays a pivotal role in entire statistics, machine learning, and deep learning. Look at here, normal distribution. So this is the representation of normal distribution. Easily we can calculate normal distribution always helps to missing value imputation also. For example, this range of marks are not available. Students' marks are not available with me. Yes, possible. If I know what is the minimum, this is maximum tail, this is maximum tail, what this is maximum tail, this is minimum tail, what is the minimum mark of the class, what is the maximum mark of the class, if I understand, and rest of the students marks are available, only within this part I am missing students mark, I no need even ask them. It is possible if the marks are normally distributed, entire class is above 50 marks, that is skewed. Skewed means it will be shifted, one tail is not at all available, because the class mark starts with 50, each and every student started scoring above 50, then it is skewed distribution, then not possible. Normal distribution means in a class person should have 0 also, in a class person should be 100 also, rest of the students should have normally distributed, plus 1 minus 1 plus 1 minus 1 difference. If that way numbers are distributed, whenever certain pattern, certain students numbers are missing, easily I can plot or understand their mark score through normal distribution. Normal distribution always helps for missing value imputation in entire machine learning study, so that they are using this normal distribution to fill the kernel values, initial values. So this is the appropriate way we need to initialize, so that he normalization, they are fixing certain range depending upon the kernel size, only one formula is used, square root of 2 by n. So the value will start from deviation, mean of 0 and standard deviation of this. Within this range, within this parameter, mean supposed to become 0, standard deviation supposed to become square root of 2 by n. With that reference, the number has to be drawn, picked, randomly should be picked within that conditions to be satisfied. Always, whenever whatever the number we picked, when we calculate mean, it should supposed to become 0. When we calculate standard deviation, it's supposed to become square root of 2 to the 2 divided by 9. So that is the way we need to follow. So now here it is given 3 cross 3 filter with one input channel, means this. If you look at in the animation, one input channel only we were using, red channel, green channel, blue channel, only one channel at a time. So that is one. Now in this, what is a filter they were using 3 cross 3. So in that case, 3 cross 3. Otherwise, what is the way is Glorot initialization or Xavier normal, that is initialization technique, in which what they are using, mean supposed to be 0, but standard deviation, it is changing, the formula is changing. So this n in number of inputs, n out number of output, so these two are affecting, the denominator is affected. Earlier the denominator is little different, now the denominator, earlier only input is considered, here input and output is considered. Within this suitable condition, the number we need to randomly pick. Every random function, even if you look at Python random function and Excel rand, rand or rand between Excel formulas, these all follows certain distribution conditions, that based on that condition only numbers are generated, not randomly, not sarcastically. For example, when we ask human, tell me the random number, we will tell randomly one number, whatever flashes in our mind, but mathematics that will not work out. We may need to follow certain background like a normal distribution or Xavier normal distribution. Like this, we may need to follow certain conditions, that is called mathematics, that's all. Random normal initialization, in which mean should be 0, small standard deviation, example 0.01, at least a little standard deviation it has to keep. With that condition, the numbers are drawn and it is initialized. And random uniform initialization, it will be always uniform interval, minus 0.05 to, for example, 0.05. It could be anything, not necessarily this. So but it is fixed uniform interval, negative side also, positive side also, a fixed range. So within that range we may need to go for initialization. These are all the initialization will help scientifically to conclude or to proceed or to calculate or to take decisions. Randomly when we do, impossible to take conclusion. So in case if you are not interested for any of this, you need to specify what is a way scientifically you can bring a kernel initialization value. That would be the real research contribution. This is called research. When we use already existing kernel normalization techniques or initialization technique, that cannot be accepted in the research world. That could be a product or a project. Whenever anyone is stepping into research, we need to come out with a new kernel initialization technique that we need to prove it across multiple database. This is the first point of research I'm telling. This could be one of the research anyone can take up. How to initialize the kernel, that is a question, research question within CNN for the better performance. That is always underlined. We can come out with some kernel, but never it will be, what is it, providing a better performance. So in case anyone is interested, this could be the research article, investigation, how to find kernel. Then always we need to start studying about kernel after understanding CNN in and out, practically, mathematically, theoretically. That's enough. Then the deeper exploration of one person should go into initialization techniques, mathematics behind of initialization, what are all the other way we can do, how we can prove it. Then we need to apply on the benchmark data set with the benchmark accuracy. With new initialization technique, near that accuracy or performance of the model when we achieve, that is the greatest achievement of research. So today I'm ending up with one of the research problem, how to find a new kernel initialization or designing a kernel. That's it. Anyone is interested can explore, otherwise not necessary, it is not a compulsion. So how to design a kernel. Today's topic of introduction is ending with one research exploratory question, how to design a kernel. That's it. So with that, today I'm concluding. In case if you have any questions, you can come forward and we can